all over India. She is a personality and she is a source of inspiration for Indian Association for Physics Teachers. And on this forum, I invite everybody to quickly contact me and become a life member of Indian Association for Physics Teachers, which is a national body having several units all over India and in Delhi too. So, isn't it, madam? Am I correct or did I speak something wrong?
Perfectly right.
Yes, and she is. So I will read out her introduction, and it's a pleasure for me. I think it's an honor for me that I speak about her. So she's a retired professor of physics from the college I mentioned. She's a coordinator of Amani IAPT Anveshika, which is a wing of NANI IAPT. IAPT is Indian Association for Physics Teachers, and all of you who are there in the audience must become a life member. It is so exciting, I can't tell you. Secondly, the Anveshikas have been started by IAPT, and Professor H.C. Verma is also totally associated with it. I suppose these were initiated by Professor H.C. Verma. Madam will tell more details. She's a 6 times recipient of National Competition of Innovative Experiments. And I tell you, colleagues from the colleges, I can guarantee you for that. If you look at those experiments offered by these innovative experiment competitions, you will feel ashamed. Do I know physics? That's exactly what you feel. And you feel like a little bit child and a small kid, and you was it, oh, I want more. So, and she has won thrice now national competition of innovative computational physics. Well, guys, let's not think that we are experts. She's an author of 8 volumes of 2 books named Understanding Physics and Concise Physics. Ma'am, we want their references to be given into our library and to the faculty also. She's volunteering for IAPT, Indian Science Academies, Bangalore Maharani Lakshmi Ambani College, Agastya International Foundation, etc. Her main objective is to make students curious and interested in science, and for this, she has conducted innumerable workshops, science demonstrations, and interactive lectures. And I tell you, when I listened to her, I said, oh my God, it's like I'm a baby in physics and so on. So thank you, ma'am, for agreeing. I mean, I couldn't imagine that you could say yes, but I was greedy. As I said on the first day, I'm greedy to get more for my colleagues. And I was enjoying the NAEST experiments that probably ma'am will talk about today. So
Welcome,
ma'am,
Dr.
please welcome.
Welcome, Dr. South. Welcome.
Thank you very, very much for your wonderful words. I'm especially when a friend is talking about you, probably they glorify you much more than you
Oh
actually
no,
are.
no, they have to
So
see
much.
everything, ma'am. They have to see everything. They will judge it themselves. They will have to see all your workshops to believe me.
Okay. Time is little very short, and
No,
therefore I
ma'am,
will
you
try to
take
keep
your
as much.
complete hour. We will adjust. We will adjust as we progress because you are our
Yeah.
guest from outside, and we will not sacrifice time. I'm sure other speakers will also, kind of do my style of super fast like this. Please share your
And
screen.
I don't know whether I really can talk that fast. So it was
No, ma'am.
wonderful.
I mean, that's my defect.
I will take my own time, and probably I will try to do whatever I can within that stipulated time. I will not
Yeah, ma'am.
cross.
Please take time till complete 1 hour. We will
Okay.
adjust in the coming sessions. No
All
problem.
right. Thank you very much. And I'm a little messy about sharing. So let me share and do my best. Okay. So what I'm going to talk about, I think the topic is very clear. In fact, Madam Punita just now mentioned about the NEST exam. I'm going to talk about the experiments that were set for the NEST exam. NEST stands for National Anveshika Experimental Skill Test. This is being conducted by NANI every year. All these years we were having it in our laboratories, but unfortunately because of pandemic, we had to switch over to online experimental tests this year. And therefore, it was a big brainstorming done by Professor H.C. Verma himself and all the members. And we came to a conclusion that yes, it can be done in our homes, and we will convert our homes to the laboratory. That is how the students starting from school 9th, 10th, 11th, 12th, as well as BSc and MSc students had been given some experiments. There is no experimental lab, there is no experimental equipments available with them during pandemic. We did not want the students to go out and buy anything. So the experiments had to be made with all the available instrument and things which are in the home itself. So keeping that in mind, all these experiments have been designed by Professor H.C. Verma himself. And of course, we have put in our effort to make it a wholesome experiment. I'll just give you the list of experiments and tell you small things about it, probably whatever time permits. And then we will see whether we can extend this further and allow our children to do experiments as and when they are doing a particular topic. We don't have to wait for them to cover that in the class and go to the laboratory. Okay. So I will go. I think I can make it a slideshow. Right. And of course, my greatest gratitude to Professor Hetsi Verma, who is the main drive behind all these activities. The experiments that were set was, one of them was balloon rolling on inclined plane. And I don't know whether all of you have understood the word balloon. Balloon is the rolling pin that we use for making chapatis, that is available in all kitchen. And we require an inclined plane. They may not have a wooden board or a metal board or anything. So they can use a divan or a small wooden piece or their benches or something like that to use it as an inclined plane, allow the balloon to roll on the inclined plane, and hence find out a variety of things. What they need to find out, there is no constraint. Nothing is mentioned to them that, okay, you do this alone and nothing else. They have to use their imagination, allow the balloon to roll, watch it roll, and then find out various things that they can find out with this rolling activity. The second experiment was load extension of a rubber band. In fact, there are some experiments in the course itself to do load extension of metal wires, etc. And from that, we find out the spring constant. But here, load extension of a rubber band is really tricky, because I don't know whether you have seen a rubber band. Of course, all of you have used the rubber band. Look at this rubber band. It is roughly about 4 centimeters or so, but it is capable of stretching, I don't know how many times, 10 times, and so on. So then if you are going to put load and extend it, find out about the rubber band, how it is going to behave, you will find that it is behaving absolutely different from whatever you have seen before. And therefore, you have to watch the rubber band extending and then find out the relation between the load and extension and whatever is possible from those the data that you collect. In fact, you will realize that this experiment was a typical experiment. We generally put some units of load and then watch the extension. Then we remove the load and then find that the extension is coming back to the previous value when you remove it. That means it is repeating. But unfortunately, the rubber does not repeat. It does not obey Hooke's law. So when you are plotting a graph of load extension, you will see things which are totally different from what you have already been experienced with. So therefore, it's a huge knowledge that you can collect from the experimental data that you have obtained. So this experiment was suggested with a lot of changes in the initial conditions. I will talk about it a little later probably. And the third experiment was UV relations, which you can determine by a lens. But do we have a lens at home? No. So how do we do the experiment? He suggested that we can take a cylindrical tumbler, which is transparent, put a little liquid inside it, and this will behave like a lens. So since lens is a very common thing which they have already used in their school level, they feel that yes, it is a very easy experiment. We can find out the object distance and the image distance and give the relation. But it is really not so. There were many other things which had to be taken care of in order to be able to measure the object distance, the image distance, find out the focal length, and then realize that the focal length is not satisfying any of the formulas that has been given in our classroom textbooks. That is the thin lens formula. It is something different. And therefore, you work on it, do a lot of research and find out what it is satisfying, what exactly it is, maybe derive the equation or watch it and then find out. And fortunately, you will see that there is a relation which is satisfying the experimental values that we are obtaining. And then it is found that yes, it is a thick lens and it very well matches with the experimental value. So this was again another very wonderful experiment. The fourth experiment was oscillations of a jharna. I'm not sure whether all of you understand this word jharna. Jharna is the device that you use in the kitchen for straining oil when you are deep frying. Okay, so if you take such a device and allow it to suspend from a particular point and then oscillate it, it will behave like a physical pendulum. It has a stiff rod and it has a heavy mass at the bottom if you are oscillating it from one end. And therefore, when it is oscillating, what all you can find out from this, again, the statement of the problem was kept open. It was an open-ended experiment. So you can do the oscillations, find out the time period, watch out where the time period is so small that you are likely to make a huge error. So how do you minimize the error? And after having minimized the error, how can you make the use of this time period from the other dimensions of the jharna and find out some profound things about a physical pendulum? Okay, that is for short. And the next experiment was refraction properties of liquids. So inside a liquid, if you put a body and then you move it, you find that the refracted rays are giving rise to images which are changing in nature. And from the study of these images, you can find out what are the properties of a liquid. And the last experiment, of course, is not the nest experiment, but madam wanted me to do this experiment and therefore I'm mentioning it. It is how do you study combination of springs using just one toy Slinky Spring. I will probably talk about it very soon and then it will become clear. Okay, so the process is, I'm sorry, can I remove this? Okay. The process is we define a question that we call it as a problem statement. And in that question, we give them small hints, what to expect from the activity, how do you go about doing this activity, what is the design thinking that has to go on in order to collect the materials that are available in and around you and to set up the apparatus to do the activities. And all these were open-ended and had a large scope for expanding and elaborating on the topic that has been given. So a small hint was given, do this and try to find out this. And therefore, you don't have to stop over there. You can keep on doing things much more than whatever was indicated in the question paper, expand it, elaborate it as much as you can, see the link of different things that you are doing. And all this was to be done by the student without any interference from a teacher. The suggestions that were there in the question paper had hinted that it could be an innovative activity. You don't have to do whatever is being told in this problem statement. You don't even have to repeat these things. You can do everything that is possible of your own and then inform us. So they were checking whether they can have some students can have some innovative ideas and introduce some creative ideas into their activity. Of course, there were small hints because they are all young children, not have done any experiments on their own. Most of the experiments that they have done is directed by the teachers in the laboratory. Do step 1, 2, 3, 4, 5, 6, draw this graph, show me. The graph should be like this. If you have done it, you have done perfectly, and therefore I give you 10 on 10. It's not like that. So everything is new and it is open. Therefore, they have to do things on their own. So there were small hints and nudging them to take at some crucial junctures so that they can take proper steps. What happened? Why it is not moving? Yeah. And of course, if they have to do an experiment all by themselves, they have to plan how to set up the apparatus, what readings to take, how best we can take what are the corresponding variables, etc. The full planning has to be done. So for that planning, what all is required, they have to set up. They will make mistakes. They will learn from their mistakes, again redo if necessary, or change any component that they require, and then complete the experiment. So for that, a 3 days time was given to them. It's not just 2 hours or 3 hours. So they can do a proper planning and do the experiment, maybe repeat it once or twice till they are satisfied. And all that they have to do is requiring some background research. They can't do anything because it is not there in their textbooks. They have not been told to this thing by their teachers. This is the type of experiment you have to do. So with our small guidance, we gave them enough time to decide on their course of action. And how do they do that? It is like an open book examination. They could refer to books, they could refer to web, to all the sources that are available. In fact, they could also talk to their teachers, their parents, their friends, whomever they feel are comfortable with, and then decide how they were going to proceed in that particular experiment. And all that they have to do or did in the activity, it is very necessary for them to observe the activity intently, what variables are changing, which are constants, identify all the independent and the dependent variables, watch out for the relation between them, and probably make a calculated guess, which we call it as hypothesis, and then verify it by doing the experiment. So everything they have to do it. And from their feedback, we learned that all these children have done, even class 9, 10 children have done a wonderful job, and they've been able to complete the experiment in a very wonderful way. They have to do the experiment. And for doing the experiment, of course, they have to see, watch out what is happening. They can do observation in various fields. They can touch it, feel it, smell it if there is any smell, and classify whatever they are doing and perform the whole experiment in the best possible way to get their outcome that they are looking for. They have to collect data. So for collecting the data, they have to note down the data in a proper way. So they must tabulate it. They must record all the values. They must write the proper headings in the units. And of course, they have to look out for the errors that are cropping into their values, choose the errors, correct their errors, minimize the errors, do their best so that they have very little error. They have to check and recheck it to be sure that they are getting something that they are looking for. And of course, relate there are many things that will be similar, differences, and therefore they should be able to relate all of them. And all this, they are doing it by themselves. They have to draw conclusions from whatever data they have collected. So they must draw graphs, charts, figures, study them critically, infer and repeat with keener vision. They can't simply infer something that the question paper hints at. And they have to draw proper conclusions, apply it in similar situation, check whether it is happening or not happening, do it again, probably for another thing, liquid, if they have done it for one liquid, and so on, and then confirm it. And all this they need to report and have to send back to the NANI group who was correcting their paper. The evaluation was extremely different from whatever we have seen before. In this, what they have to report was very necessary. They have to give their experiments, tabular columns, illustrations, graphs, calculations, uncertainty, write it in their own way, mention what are the precautions that they have taken, and of course, neatly display it in a planned way for the teachers to understand what they are trying to say. And after that, we had a wonderful session with all the evaluators, 120 teachers from all over India to correct these papers. We corrected it, recorrected it, discussed it, and then finally announced the prizes. So I'm not going to tell more about it, but I will go to one of them or few of them within the time. Please tell me when I should stop. I'm not able to see the watch. Kindly help me.
Ma'am, I will not ask you to stop unless you show us at least a little bit about the 5 experiments that you spoke about, either a photo or a
Five
movie.
experiment may be difficult.
No, ma'am, at least just one photograph.
I'll try. I'll try.
Yeah,
I'll try
just
to
a
do it.
photograph or a movie or
Yeah,
something.
I will try to do whatever best I can do.
Yes, ma'am,
Yeah,
please.
yeah. What am I showing? I don't know.
Ma'am, you are showing report
One
slash
minute.
publish.
Uh,
Report slash publish is what you are showing, your last slide, which you talked about.
no, but just
What,
1 minute. I always mess up with my things.
ma'am, what do you want to show now? Some other screen? Some
I
other?
want to show, yeah, I want to show the PPT of one of these experiments.
So, ma'am, you have
Where,
to stop sharing and then start sharing.
oh, I have to stop sharing and then I
Yes,
have to
and then
start sharing
share,
once again.
whether
Where
it is
do
a
I?
tab or a, ma'am, while sharing, you can either share
Sharing.
your
Yeah,
whole
okay.
screen.
I'm sharing. 1 minute. Sure.
While she does this.
Sorry, I'm really sorry. I am
No, ma'am,
really very
please don't say
sorry about
sorry.
this.
I mean, I
Uh,
just want to
okay,
convey to our
this is
colleagues.
one of the experiments. This is one of the experiments. This, of course, was not a nest experiment. I understand that there is an experiment for the first BSc children about determining the spring constant of a spring. Okay, so this we had done it. In fact, I had done it for one of these competitions, which I think ma'am mentioned just now. It was one of these experiments long back for the national competition for innovative experiments. And this I realized is a very nice experiment which can be done by the students at home and give the results online. And therefore, I'm trying to show it since it is there in the thing, their syllabus. The best part of this experiment is I took just one Slinky Spring. I hope you know what a Slinky Spring is, and then used to find out the spring constant of a number of springs, and then combined one, two springs together and found out what is the spring constant of two springs connected in parallel using just one Slinky Spring. Okay, so I will tell you about it a little longer. What is happening? Yeah. So what we can find out with
Ma'am,
this,
it is not, ma'am, it is not, it is just showing you us the Windows Explorer where you click that spring constant parallel combination.
oh, you're not seeing, but it is saying stop sharing. You are sharing screen.
Once again, ma'am, I'm seeing the Windows Explorer where you, from where you chose this file.
Arre,
So,
arre.
you chose that tab. Now again, stop sharing, and your
Huh,
PPT is now open somewhere, and then you
huh.
share again.
Arre, dhat teri ka. It's a real big job for me. Okay. So
Nothing,
now
ma'am. Just
I have,
while sharing screen,
okay.
you have three possibilities, and you,
Okay, I did it, I
yeah,
guess.
here it is. Fun with
It's
toy
done.
screen.
Done.
Yeah.
Okay, now I'll just repeat the previous slide. Okay, I was just talking about uh,
Slideshow, ma'am. Slideshow.
slideshow. Okay, Aridha, oh my lord. Huh. Okay, so this is the first slide. I'm sorry. So we wanted to find out the spring constant of a combination of springs, a number of springs combined together, either in parallel or series, etc., etc. And all that has been done with one Slinky spring. Okay. Now, what did we find out from that? One toy spring has been used, but many concepts have been determined. We first found out the effective mass of a spring when it is in the static mode. Then we found out the effective mass of the same spring when it is in the dynamic mode. And these effective masses, I've called it as MD and MS. Then we found out the spring constant of a number of springs. Two of them I mentioned. We found out what is K1 and what is K2, both by static as well as by dynamic methods. Then we found out the first spring, let us say, had a number of turns n, the n1, and the second one had a number of springs n2, that we repeated for a number of such springs. And then we found out what is the relation between the spring constant as well as the number of springs. And the last thing we did is we took the same single spring, divided it into two parts, and then used it as parallel combination and found out the spring constant of the parallel combination itself. So what are the static and thing all of us know? If you simply keep the spring in the vertical direction, the spring will not remain in its original position. It will stretch a little. Why does it stretch? Because it has some mass of its own thing, and that is why it is stretching, even though you have not loaded the spring with any mass. And the relation when it is stretching is the force is equivalent to K times the extension, which I've written over here, mg is equivalent to Ke. But this M should contain both the mass that you are loading as well as the mass of this spring, which I'm calling it as the static mass. Therefore, this whole equation can be rewritten as Ke is equivalent to M plus Ms into G. Now, this is all that you need to give to the children. You don't have to give anything else, and ask them to find out the spring constant. So they will be able to decide that, yes, it is a linear function where K can be determined because extension and mass are the two variables. So if they can plot a graph of the extension versus mass and find out to their surprise that it is a straight line, and since it is a straight line, they can find out the slope, they can find out the intercept. From the slope, they can find out the spring constant, and from the intercept, since the slope is known, they can find out what is the static mass. Okay, so this is by the static mode. They take the same spring and then you can make it move or oscillate. Then we call it as the dynamic mode. Since it is oscillating, it will have a time of oscillation, and the time of oscillation is related to the load that is put on the spring, given by this relation. T is equivalent to 2 pi square root of M plus MD divided by K. This is all that you need to give it to the children and then ask them to find out K and MD, and I'm sure they will be able to do. Since there is a square root, to make a proper linear equation, square this equation, then you will get another equation, T squared is equivalent to 4 pi squared by G M plus MD. And then they need to plot a graph and then find out. Experimentally, it is always ideal to repeat the experiment a number of times by changing your M and then noting down the corresponding T and then plotting a graph. So they need to plot a graph of T squared versus M. And then since it is again a straight line, they can find out the slope and the intercept. From the slope, they can find out the spring constant, and the intercept, they will take the help of slope and find out the dynamic mass, effective mass. Having told this, I will now show you how exactly the experiment can be done. This is the Slinky Spring that I'm talking of. The Slinky Spring has many number of turns, roughly about 100 turns or so. And this, you will wonder, how can I get it at home? And surprisingly, a similar stuff is available in these plastic shops, which children or ladies, I think, adore wearing it in their hand as bangles. So it is multicolored, it is very light, and it has a number of springs sorry, which can be a number of turns in that spring, so you can use it for this purpose. Okay, now I was talking about using one spring, you can make it a excuse me, you can make number of springs. So a spring has a definite number of turns. So first I decide, let me make it a spring of 30 turns. So since there are 90 turns, I choose only 30 turns from one end and then keep the rest of the springs on a setup where I'm not going to use it as a spring. So for doing this setup, it is very easy. You just need two bars on which you can rest a ordinary steel scale. You can make these bars by books or whatever it is, and then make a elevated seat, and over that keep a steel scale. Place the Slinky Spring, the part of the spring that you want to use it as a spring, you let it hang there below, and the rest of it you put it on the top. Okay, now you have to study the extension with respect to the corresponding load. How do you put the load? You don't have any weight hangers or things like that at home. So how can you do the load? This is very nice. Since you have so many turns, take 5 of the turns at the bottom, 5 turns at the bottom, and tie it up with a thread. Tie it with thread on either side so that it uniformly gets constrained to form a small ring. That small ring is connected to the spring all around the circumference, and because it is condensed into a mass, it will change the extension very soon when you have completed this activity of tying it together. Therefore, this becomes the mass corresponding to which the extension can be found out. How do you find out the extension? Just keep a steel scale, probably a long enough steel scale, just behind the spring, and you will be able to find out the extension. Now from this, you can keep on changing the load. First you take 5 turns, then you take 10, 15, and so on. But please remember, if your number of turns had to be 30, every time it should continue to be 30. So if you take 5 turns from the bottom, release 5 turns from the top, so that the number of turns continue to be 30 for the entire experiment. So by doing this, you can do the extension, load extension values. I have plotted the load extension graph. The extension is on the y-axis and the load is on the x-axis. Of course, load, I have written it as the number of turns. Of course, I can convert it. If I know the mass of each turn, I can find out what is the load. And from that, when I repeated the experiment for a number of times, I got a wonderful straight line. From the straight line, I can find out what is the slope intercept and then find out the spring constant. Look at the value in CGS, it was 1495. And I also calculated from the intercept the static mass with respect to the original mass. I found it as a fraction. The original mass, I actually found out mass of each string. Therefore, 30 turns, therefore the original mass can be found out. Now from the graph, I found out the static mass, and the ratio was equivalent to 0.5. That means the static mass is roughly 50% of the original mass. I repeated the whole experiment, made it oscillate, and then find out the corresponding time and the mass, and got a straight line. From that, I found out the spring constant as 1431 for the same spring. very well matching with the previous value with the uncertainties that is thing incorporated in the experiment. And the corresponding mass in the dynamic method was different from that of the static. It was only 40%, while in static it was 50%. So if you want to conclude, it is very necessary that you have to repeat the experiment a number of times. So I did it for a large number of springs, 30 turns, 40 turns, 50 turns, and so on, and then concluded that the static mass is always close to 50% and the dynamic mass is always 40%. And of course, the Ks were matching very well. So since I had done it for so many springs, I could also tell the relation between the spring constant and the number of turns. I realized that n was inversely proportional to k, and therefore I plotted a graph of k versus 1 by n. And to my surprise, I did get a straight line. I've taken only 3 points, but I've done it in large number of time. And from this, I'm also able to tell that this is the relation between k and n. And after that, so I have used one spring as many springs. I'm trying to repeat that over and over again. Achha, the next part of the experiment was to find out the parallel combination. Generally in the classroom, we ask them to take two springs and fix it at one thing on top and probably connect the two springs together, put a hanger and find out the thing extension. But in this case, you can see that wherever the mass is kept, the extension is much longer than the surrounding or the left and right edges, which means that the extension cannot be found out accurately if you do this. So this is the first point that has to be noted. And if from the theory, they must have understood that whenever you have connected the two springs parallelly, the total combination spring constant is equivalent to the sum of the individual springs. So if they know this, they should be able to do the experiment by taking the spring as shown in the figure over here. I have taken the same spring, let us say 30 turns on top and 40 turns at the bottom. I want to keep one end of the spring fixed, and that I have done by keeping a scale on the top and another scale or whatever I have used, a spatula, and have kept it fixed. So these are the fixed ends of the spring. I have to connect it, the other end, to only one force, and therefore I have tied the number of turns in the center, which becomes my load. So I can do the same thing. Each time I can put 5 turns, 10 turns, 15 turns, and so on. But we must make sure that you have to release some turns from the top and some turns from the bottom, so that you always have the same spring that you have decided to start with. So if it is 30 turns and 40 turns, make sure that it is having 30 and 40 turns each time when you are taking the reading. So from this, if you look at the theory, you will realize that I did the same extension versus what mass. Again, it gave me a straight line. And from that, I found out both the static mass ratio as well as the dynamic mass ratio, which again was 50% and 40%. And surprisingly, I did calculate the spring constant from this graph intercept. It was 4425. And I already knew the spring constants of the top and the bottom spring, which I added it together, and I found that they were matching. Therefore, the experiment is successful, and I'm able to say that yes, Kp is equivalent to K1 plus K2. So I've done it both for dynamic mode as well as for mode, and got the same numbers, 40% and 50%. So this I'm just concluding. This was how it was verified, and the whole experiment was done. What are the conclusions, etc.? I've just mentioned it. Yeah, another thing is, if you are going to do it by two springs, the way I suggested is done in the college. And if you are going to take two Slinky springs, you can't have the two springs of different type, K1 and K2 totally different, because then they will look like this and you can't put a single mass and hang it. So it is not really a feasible way. What I suggested would be a better way of doing the experiment in this case. Okay, I think I will stop sharing and go to the next one. Is it okay?
Yes, ma'am. Yes, ma'am.
Yeah. Where is it? Now, where do I go?
So this very first experiment makes us realize we think of experiments that can be done only in the laboratory. I mean, she's just going to give us a flavor, and it's amazing. With the Jharna experiment, you can do a complete compound pendulum, and I mean, it's amazing. Just look at it; you get hundreds of ideas. Yeah, ma'am. Please go ahead.
Yes. I need to share it again. Correct? Terika, I'm doing all rubbish.
Ma'am, you want to show the photo or the Excel sheet?
No.
Or
I will show the photos first and the Excel sheet. I think I will go to this.
Ma'am, you are sharing the screen. Then when you will click on the photo, it will not be visible. So I suggest the
I see.
following.
New share. Okay, let me say.
No, ma'am, you share your entire screen.
I can't do it. What do I? How do I do it?
Very simple. Just stop sharing. Go to the green button on the
One minute.
bottom.
1 minute. Let me do it. I stop sharing. Then
Go look at the green button on the bottom. It says
yeah,
share
share
screen.
screen.
Then it
Yes.
says, then
Hmm.
it says to you,
Hmm.
it says to you an entire screen. So you see a window pops up where you can see yourself all black. So you can see yourself on something called screen.
Yeah. Okay.
There
Yeah.
you can see yourself.
Hmm. Yeah.
Click
No,
at
no. That
that.
is the screen where the entire group is visible. Should I?
Yes, exactly.
Okay. Okay. Okay.
Because
That
that is because you are now, you just please minimize your Zoom window with the
Hmm.
minus sign, which you can see on right top.
Okay. Okay. And
And
then
then whatever is there on your computer screen will start becoming visible to us.
is it visible now?
Not yet, probably coming. So you have to
No,
first
no, no, no,
reduce.
no. I'm wasting a lot of time. I don't know
No,
how
it's
to
okay,
do
ma'am.
this.
Please, please.
Ah,
We have to go
yeah,
slowly. You are
yeah.
right now
Ah,
sharing the screen. And when you shared the screen, you chose the screen. The word screen should have been written that.
Am I sharing anything now?
You're not sharing anything right now.
Arey
So
dhap
you have to
terika.
click at share screen. Ma'am, please click at
It
the
has
button.
vanished. It has
No, it's
vanished.
not vanished.
I can.
I'm telling you
No,
where
I
it
should.
is. Ma'am, I'm telling you where it is. Just take your mouse either at the top corner or to the down corner, and a
Hmm.
horizontal
No,
bar
no, I'm not
appears.
seeing myself first. 1 minute. I'm not seeing anything.
It's okay.
Okay,
It's
I'm
okay, ma'am.
just
Don't
closing
worry.
all these.
Take your time.
Okay,
Take your time,
yeah.
ma'am. Take your time.
Hmm. Okay, now I will go to share screen.
Yeah,
Okay.
and then you can
Then
see
I will
then you can see mini
whiteboard iPhone
tabs
screen. Screen.
screen. And now what
Huh.
you see on the screen, we will see on the screen.
No, I see the entire thing, picture of all of us.
Yes, very good. Now you click at that first.
On screen first and then share.
Yeah,
Screen first and then share. I shared.
share. Yeah,
Yeah,
exactly.
I shared.
Now, ma'am, yes.
Hmm.
Now I can see 10 amazing science experiments. You're scrolling up videos. This is now
Hmm.
visible to me.
But this is not what I want.
It's okay. It's okay. 1 second, ma'am. This is a tab which is open on your screen. It
Huh.
says My Files OneDrive. Just minimize it. Ma'am, just minimize this.
No, just 1 minute. I have kept everything ready, but I don't know what I'm doing.
Ma'am, you have to go to your folder. Please take your time. Find out your folder,
Documents,
wherever it
something,
is.
Rishika. Okay,
Meanwhile, yeah.
I'm opening all of them once again.
Yes, here it is. You can choose your folder. Take your time. So, colleagues, I was just mentioning that the 5 beautiful experiments that she mentioned about, 3 of them are directly applicable to the undergraduate laboratory, and one is Jharna for compound pendulum, this one for spring constant, and so on. Yeah, here, see,
Okay.
it's here.
Now I have come to one of these experiments. Okay. Oh God. Okay, I'll start with extension. Okay.
Yeah, here it is, ma'am.
Okay. Huh?
Yes, and now if you
Right.
make the photograph bigger, we will also see
Hmm.
the photograph big. Whatever you see,
Okay.
we see. It's as simple
All
as that.
right. Okay. Then I'm going to show them the pictures first.
Yes.
Okay.
Yeah,
Right.
wonderful,
Now,
wonderful.
one of those experiments was to study the load and extension of a rubber band. Okay. So I chose first an elastic piece, which I wanted to find out how the extension is for loading it. Now, this elastic piece has some thickness. So all these children have not been told. They have to decide for themselves. So I'm showing you what I have done, and I'm assuming, or most of the time, children have done a wonderful job, much better than mine. So I'm showing my pictures. Just ignore the other side of the picture, very bad photographer. I have taken an elastic piece. Since it had some thickness, I've made a loop over here so that the elastic doesn't get screwed up. And at the bottom also, I've put a small rod so that the elastic is standing straight. Then I put 2 loops on either side of this rod, put a small plastic bottle, and in that bottle, I put some weights, which was the load. Watched the extension. For watching the extension, I put a steel scale behind that. And again, the steel scale, I didn't have to fix it. I simply kept two magnets on either side of the steel scale. Since it was an iron shaft, it fixed very nicely. And there was some distance. Because there is some distance, I'm likely to make a error in taking the reading because of parallax. So to avoid parallax, what I did, I'm just showing it to you. Okay, what happened? Yeah, so I'm showing you that is a small scale that I have taken to find out the reading both at the top and the bottom, and hence find out the length. Oh, I'm sorry. And then we had to load it. At home, we really do not have any mass like a weight hanger or something like that. So in the question paper, it was suggested very beautifully that you could take a small cup, fix it with a vertical handle, and use some amount of liquid as your unit of mass. So if you put 1 cup of the liquid, it will have some unit mass m, and then you put 2 cups, 3 cups, 4 cups, and so on, and then load the thing extension. That was your suggestion, but of course it was not restricted. You can decide whatever you want to do. And therefore I found in my garage a number of some tiny studs in the door studs, which was available, 40-50 of them. I said I will take that as my unit weight and then find out. So that's what I have done. I've taken a plastic container to make it a pan, and the plastic container has to be connected to the rubber band. Of course, since that is your experimental part that you want to study, you have to minimize the length of the rubber band that is wasted in tying up at the top and the bottom. So I made a wonderful arrangement over here. I put two small magnets and squeezed the rubber band, a little portion of the rubber band into that, so that it hang from the magnet. And the other end of the rubber band, I took those electrical pins which are available, discarded ones. They have some screws and a hole. I put the rubber band inside the hole, and the screw was a small hole was punctured onto that rubber container, and it was fixed over there. So that's how you could hang the rubber band easily without disturbing the length, etc., etc. Then since I'm using masses whose values are not known, I'm just showing it once again. Values are not known. This is where the rubber band has been squeezed in between the two magnets. Okay, now since these units are not known, it is necessary for me to find out what is the mass of each of them. So I use three types of things. This is one. Then I had some spherical spheres, metal spheres, and I had some weights which was already identified as 10 gram, 20 gram. I used all of them to do the experiment thing repeatedly. Now, how do I find out? Again, I don't have a weighing machine which is very accurate at home. I just have a kitchen machine. So how do you use the kitchen machine, which has an error least count of 20 grams, to find out some tiny masses like this? And it is very important to know what are the masses which you are going to use as your unit. So what I did is I just took a number of them and put it in the weighing pan, which was weighing probably 300 grams. So I counted, added and subtracted to make it a whole number. Once it is 300 grams, I count the number of turns, and therefore I have an uncertainty of 20 grams. In 320 is a reasonably small value, but I need to find out the mass of each of them. And therefore, if when I divide it by 300, it becomes a very, very small factor. And hence the mass is 2 grams, but the error is so small that I can consider that uncertainty for my measurement. Now that was again another thing that needs to be taken care of, and the children had done a wonderful thing. To extend the experiment, the rubber band was done. Then we had to take two rubber bands and put it parallelly. So instead of cutting the two rubber bands and putting it, you can just take one rubber band, and of course the two sides are parallel to each other. Again, put a hanger the way it has been done with one loop, and then put a loop on the top to hang it, and use the whole apparatus to set it up for parallel rubber band. I did that. Okay, I'm showing it with different, I think I've done it repeatedly for the thinner rubber bands, thicker rubber bands, and so on, so that there is a variety in what I'm trying to do, and see whether they are behaving in the same way or not. Yeah, I think that is over. How do I go to the next one? How do I go to the next one? Stop sharing again?
Yeah, ma'am. Are your photographs of this section over?
Yeah. I've again gone back to...
Again, ma'am, share screen. Press the green button down. Whether it is down or up depends upon yes.
This I have already finished.
Yes, now you go back to,
Okay, I
just
will
choose
show.
your folder. Ma'am,
Yeah.
just choose the folder that you want to see. Whatever you see is what we see.
Are you seeing now?
I'm seeing these various photographs in small,
No,
small
no, no.
ways.
Are you seeing Excel sheet? No,
Experiment 4, extension of a band.
no, 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 no. I want to show you the Excel thing.
Ma'am, once again, you clicked
Hmm,
at it, but
hmm.
then you have to minimize this window that you, from
Yes,
where you
yes,
chose
yes.
it.
Actually, I'm doing some gadbad. Okay. Is it all
Yes,
right?
yes,
Can
yes,
you
yes,
see?
it's
Yeah.
visible now.
I'm just showing the values that you will get, and it is fantastic to know that yes, it behaves like this, and it is not that simple. Okay, just show you a few things before I go to the next experiment. Okay, first of all, I used those weights and then found out the corresponding loads. I hope it is clear. I put them some certain number, 1, 2, 3, 4 metal balls. Each of them were weighing 33 plus or minus 2 grams. And then I did it load increasing, load decreasing, therefore found out the average extension. And from the extension, when I plotted the graph, extension versus the load, I get a wonderful thing. They are not repeating each other. The load increasing was in blue points and the load decreasing was the orange points. And they are not repeating each other. That means there is some gap in between the two curves, and therefore it is showing a hysteresis. So that was an eye opener for me. And secondly, the expansion with respect, I'm sorry, the extension with respect to the mass was not a straight line. Therefore, it was not obeying Hooke's law. All these you could conclude very easily from your graph and say that yes, the rubber band is not like the other things that we use in the laboratory. Then what we did is we had put one thing unit, let us say 33 grams each time, and found out. Then we repeated the whole thing by taking 2 times the mass. That means instead of taking, oh no, no. I think this second one is I repeated the same rubber band, same units of mass once more after doing the first time. First time I calculated that there was a hysteresis, and this area of the curve I calculated and found it was equivalent to 147. When you repeat it another time with the same setup, you find that the hysteresis area has become very, very small. Look at the difference between the two things. Now, this tells you a lot of things, that the rubber band is losing its property if you keep on using it over and over again. And that is what we have seen in our daily life. When we use the same rubber band 2 3 times, after maybe 10 times it snaps because it loses its property each time you are stretching it. So that was very clear from these two values. Then we did the change the mass. Instead of having 33 grams each time, we increased the weight 66 grams each time, and then calculated, did the whole thing all over again, and found out what is the corresponding hysteresis over here. And by doubling these masses, I found that the hysteresis area was very much different from the first time. This is 165, while the other one was 147. So there was a difference between this. This was a doubling of mass, was from 33 to 66 is a small mass. You do this whole thing probably first time if you take 30 grams and second time you take 300 grams, you will realize the difference immediately. So it all depends if you are stretching the rubber band with a small force, little by little to its maximum length, or if you are stretching it with a huge force and making it maximum length, it differs. So that is what was clear about from this experiment by changing the units of mass. So the hysteresis loss did not match when the mass quantum was changed or doubled. Then I think we did the whole thing once again. Now this hysteresis was totally different from the hysteresis that we are aware of in magnetic materials, etc. And what was the difference? If you repeat the experiment and see it, you will find that if it starts from a particular length, when you decrease the weight, it does not come back to the same length. It becomes much longer than the previous one. Suppose you start the length with 3 centimeters and you keep on increasing the load, get some thing, maximum stretching, whatever possible, and then you keep on decreasing it. When you have removed all the weight, it will not come back to 3 centimeters. It will be 3.7 centimeters, 3.6 centimeters, which says that it is getting stretched. And that was very clear from your graph, that your hysteresis was not a closed loop, it was an open loop. So that again was an eye opener. And besides, you also have to find out the area of the hysteresis. Now, if it is an open loop, it is very difficult for you to use any software to find out the area. So we also expected the children to find out the area, but they have to use their technique. How do they find out? From one graph, they find out the area between the two ordinates starting and ending. Again, they find out the area of the lower curve, let us say, and from the difference, they can find out the hysteresis area. That technique I have used, and some children have also used and found out the hysteresis. Again, it was not mentioned in the question paper that they need to find out the hysteresis loss. It is up to them to do whatever they can. They were simply asked to plot the graph and conclude whatever they understood from the graph. Okay. Then another thing happened, which was very interesting, and that is by keeping the units of load not immediately one after another, but by giving time for it to relax. Now, what did we do? We allowed to increase the weight. I've taken over here 4 units, 8 units, and so on. And each time I put the load, I allowed it to rest for 75 seconds. Then I did put the another load, allowed it to wait for 75 seconds. Again, I did the same thing for load increasing. When I removed the load, after removing a load, again, I allowed it to rest for 75 seconds and repeated it. And surprisingly, you will see when I first kept the load, if the reading was, let us say 17, if I allow it to rest for 75 seconds, the reading automatically changed from 17 to 17.1. Each time you will see when it was 18.9, after 75 seconds, the reading auto, that means stretching was happening even though nothing you were doing to the rubber band. With the load over there while it was resting, it was extending all the while. So the extension was visible for load increasing. But to my surprise, when I was decreasing the load, the change was even more. That means first reading, let me say, was 23.6, or no, 21.8. I rested for 75 seconds and it became 23.6. So that is how the difference while you were removing the load was much more than the change in the increase of load. So that was again another thing that you realize. So what does it say? It says that when you are using a rubber band, if you are loading it, some thing deformation is happening. When you are removing the load, a different deformation is happening, not the same deformation. So there is hysteresis, plus there is some other additional losses taking place when you are loading and unloading it. So that was again another new thing that I observed, which I had not realized before. Okay, what else did I see? Of course, I wanted to do it for parallel thing. For one rubber band, it showed me some kinks, which I discarded it. And then I did the whole experiment once more with a thicker rubber band. And of course, whatever I had seen for a single string, single rubber band, I did see it for the double rubber band also. The features were similar, but the area of loss, etc., was totally different from the single case. But I could not relate like I had done it in the previous case. I found out the spring constant of one. I should be able to find out the spring constant of the other and say that this is the link. Kp is equivalent to K1 plus K2. I could not do anything like that in terms of the hysteresis loss. So that again, I realized that there are many more things which are happening, which is probably beyond my observation, and therefore I'm not able to link it up. Okay, so this is one of the experiments. I think I will not show anything else over here.
Ma'am, a glimpse of those experiments which you
I think
mentioned.
I should stop. What, Punita?
No,
I
ma'am.
think
No, ma'am. Just one photograph, ma'am. Please, just one photograph.
I will show you what it is like.
Yes, just one photograph of the UV experiment, the Jharna experiment, and the Velan
Okay.
experiment. At least
I
the
think
Jharna, because it is just compound pendulum. Just choose
uh,
your folder wherever it is. So
yeah.
why I'm insisting is the following. That I mean, I've also dealt with this laboratory of mechanics several years, and it was really amazing for me. And I had thought of
This
this.
is the Jharna experiment.
Yeah, ma'am. The
So
photograph.
oscillating it from one oscillation, is it thing sharing? No.
No, once again, ma'am, you chose a movie MP4 file,
Yeah.
so you have to first reduce this white window.
I'm going back to I don't know what.
Ma'am, you share your screen again.
Yeah. Share
You share your
screen.
screen again.
Okay. Then I will do this. Then I will
No,
share.
ma'am. Yeah, 1 minute. Yeah, it has gone to share screen mode. Yes, exactly. Exactly.
Okay.
And
Okay.
while you play the movie, we'll be able to
Yeah.
see, I'm sure.
Can you see?
Yes, ma'am. Yes, ma'am.
Okay. This is when it is oscillating from top to bottom. Okay. Then the other way around also I have sure thing. I don't think I have a figure. I have oscillated from this end, that is the bottom end, and the whole mass is down. Of course, both of them are simple pendulums. I'm sorry, physical pendulums, and therefore you can find out whatever is required from this
Yeah.
both the situations. And of
And
course,
there
they
is,
will be different. So what we found out is the radius of gyration of this thing, physical pendulum from this experiment, one of it, and showed that the radius of gyration is different for the two cases. Once it is hanging from the handle, once it is hanging from the body. And they are different. And of course, we also found out the dimensions of the physical pendulum, which is different at different locations, and thing made a sort of a picture of that. Okay.
yeah. So, ma'am, actually, that means at home we can give a flavor to those students who can still not come to college by
Yes.
actually working on a compound pendulum
Working
at home.
on a
And
compound
that's
pendulum.
the syllabus of the first semester, which is going to be home for the next 3 months. Still, it looks
And
like
they
that.
can complain saying that they don't have a time, therefore they cannot find out the time period. Luckily, the mobiles have a stopwatch, and
Yes.
therefore they can use the mobile to find out the time period. So that is the best part of it. You don't need anything else. You can use this from the kitchen and find out, do an experiment.
And ma'am, we you had also instructed how to find out the center of gravity, if you remember. So this
Yeah,
whole jharna was balanced on a particular uh,
pointer. Yeah.
sharp piece, and there it was balanced to find out where the CJ is.
CGS. Yeah,
Yeah,
wonderful.
exactly, exactly. Ma'am, we need another lecture from you someday with only the details of all these experiments,
We'll do
so that
experiment wise. I think that would be better. It is, I'm not able to do it quickly. And probably I have the habit of telling everything about a particular experiment. So it's taking me too much of time. So please pardon me for the delay.
no, ma'am. Can you please give a photograph or show a photograph of how the UV relation
Yeah,
apparatus look
wonderful,
like?
wonderful, wonderful. I think I will show that. It is just the UV experiment actually, I think, made us realize much more than what the question paper was asking. The question paper said that you take a cylindrical, are you seeing? Or
No,
again,
ma'am.
the
First of all, you stop this jharna
same
photograph.
thing over and over again.
So,
Share.
ma'am, share screen again.
Yeah, okay. I'm doing the same mistake every time. Yeah,
No, ma'am,
okay.
it's not a problem. It's okay.
Okay, now you have this glass. It is a cylindrical glass. Fill it up with liquid, not fill it up, whatever 2-3 centimeters of the liquid, whose refractive index you can find out using this experiment. Or the liquid and the glass, which is curved, behaves like a lens, and of course, a thick lens. Therefore, you can find out the properties of this thick lens by noting down the object distance and the image distance. Now, where is your object or where is your image is the next question. So we first used light. Light can be used from your laptop, I'm sorry, your mobile itself. The mobile has a light. So you can use that light to form the image and the object point. Since it is a divergent beam, you can make a slit with a cardboard, allow a narrow beam to form the incident beam. Now look at this narrow beam that I'm showing over here was my incident beam. If I slightly move the mobile to the other side, I can make it inclined on this direction, mark these two lines, and this will become my object position. Therefore, I can find out the distance from the object to the center of my lens as the object distance. Similarly, I can find out now when the light passes through this glass, it is going to get deviated due to refraction. Again, you can have two such beams and you will find the two beams actually meet. They are convergent, and from the meeting point, you call that as the image point and hence find out the image distance. So the experiment is very simple. You change the position of the object distance. Every time you will have a changing image distance. You will find that as the object distance is increasing, the image distance is decreasing. Therefore, it is behaving like a lens that you have already learned about, and hence find out the focal length. What is the focal length? 1 by u plus 1 by v should give you the power 1 by f. So from that you can find out the focal length. But what else did we see other than that was more important for me. So you can see that some light, extraneous light, is coming from the left side. Now this extraneous light, which is supposed to be white light from the mobile, is actually showing me a lot of colors. Therefore it has blue, green, etc. spectrum, and immediately I know it is going to produce chromatic aberration. If I want a perfect value, if I want a suitable value, then it is necessary that I should take care of the chromatic aberration. So this also we did by taking laser light of different
Ma'am,
wavelengths.
can you zoom towards the, can you zoom a bit? There is a magnifier right on top. Can you, on the top of this photograph, you have this small magnifier right next, not right
Uh,
side, left side, ma'am.
Left side
Ma'am, right
magnifier.
above the photograph, there is this recycle bin, and left to it is the magnifying glass. Next to it,
There is
next
the
to it.
top sharing arch. Okay, this is the magnifier.
No, ma'am, the plus sign,
No,
it's rotating, ma'am.
it is
Okay, it's
rotating.
okay. Now you
That's
just,
okay. No, no.
ma'am,
I
just,
think I will just show the other things. Okay, now can you see something else?
beautiful, beautiful.
Okay. Now this again was not mentioned in the question paper. So it was up to the ingenuity of the student to show that yes, something like this is happening. And this happens, this is again a aberration which is happening because of the shape of that lens. It is a wide thin glass having a diameter of about 6 centimeters, and that is the one type of aberration. Now this is a beautiful picture. All of us have seen this picture when we are sitting in the dining table having water, but we have not realized what it is. Have you have you realized that you get a picture like this? If light is shining on your glass, then the beam of light which is getting refracted and coming out is like a fan. Why is it happening? It is happening because of aberration, spherical aberration. This refracting surface is very wide. So the marginal rays, let us say the two extreme rays, would have met over here to give me the image point, while two paraxial rays, which are maybe two rays which are coming from the close to center, would meet at some other point, and therefore it would give rise to an image very much different from the first case. So this is happening all the way from this end to that end. Therefore, the image points are at different values, giving rise to this fan-like structure. So once they see this picture, it is very clear that they are going to get error due to spherical aberration because they are studying refraction, image distance, and object distance. So this was the biggest challenge for them. You will realize that some of them have shown very erratic values without realizing that yes, there is spherical aberration. We have to take care of the object and the image points for either paraxial or marginal rays. We can't mix and match. So when you mix and match or take different points, the image distance is going to vary tremendously for the same object distance. Object distance may be 3 centimeters, but image distance will change from 20 to 25 or 30 or 35 like that. So you have to take care of that. So that was another very important thing that the children should have realized and have done it very well. Some of them have done it wonderfully. So that I'm sure would have realized. And if they mention it that yes, they have realized and they're taking care, obviously they get much more points than the other children. Another thing that we have seen always when we are watching, we are having our lunch and dinner on the dining table is this. Please watch it. From the inside, if you are looking at the liquid of the liquid surface, you find that there is an image, cusp shaped image like a cup like this. Is it visible?
Yes, ma'am. Yes, ma'am.
Now, why is this happening? Can anybody suggest? You can unmute and tell. Okay, that doesn't matter. Now, this is happening because of reflection through a curved surface, which is having wide aperture. So when the light is falling over here, it is meeting at this point. When the light is getting reflected from here, it is meeting at this point. And therefore, it is giving rise to this cusp over here. So all the meeting points are different for different pairs of light coming from different positions of the curved surface by reflection, and therefore this is spherical aberration by reflection. This was also something which was very interesting when we actually took time to study. This of course is showing you that there is chromatic aberration and how you can eliminate that. Okay, so this is about, yeah, I'll switch it off and then you told me to show the others. There you go. Again, I share.
Ma'am, even the position of the mobile with respect to the tumbler was very interesting. How the students focus the mobile, its light through the slit to have the light pass through the tumbler.
Yeah,
Ma'am,
that
same
was
procedure,
very
yeah.
interesting. Yeah, interesting actually. I'm not showing that. I don't have a picture over here straight away. What is the next experiment? Spring I have finished. Extension, properties of the liquid. That also I'll just show you the picture. Yeah. Okay. I'll show you some things.
Ma'am,
No, I
it's
have to
good to have
share
a
again.
trailer.
Again, I'm sharing. There we go. I'm doing the same thing over and over again.
No problem, ma'am. This is the trailer.
I'm forgetting. I'm forgetting.
No, ma'am, no
Now,
problem.
now, did you share? Did you see? Are you
Now
seeing?
we are seeing your Windows Explorer, different containers, different liquids. Now you just
Yeah.
click at one
Okay.
photograph, whichever you want.
Yeah. Yeah. Okay. Now this was the one of the
Ma'am, it
experiments.
has not got magnified. You have to now minimize this this Windows Explorer. Then we'll be able to see.
What happened? What happened? What
Ma'am,
did I
you
do?
just a sec.
Should I
Ma'am,
stop sharing?
you clicked at the photograph.
Hmm.
Did you double click at the photograph?
Yeah. Yeah.
So you have to reduce your Windows Explorer window. Only then you can show this photograph.
Is it visible? I think I'm taking too
Yeah,
long. Is it
yeah,
visible?
yes, yes,
Yeah.
yes,
Okay.
yes.
Okay. Now, in this experiment, it was necessary to put an object into a liquid of water, and from the movement of that object, you should find out what are the relation between the shift, refractive index, etc., etc. It was a little complicated experiment, though. But here I'm just showing you that when I put the object, my object was a steel scale, which I put it vertically down, which had a particular width. Inside the liquid, it was looking much bigger. All of us have seen it, but we have really not measured. So now you need to measure and find out what is the magnification. Now, how will you measure this width inside? It is very difficult. So we arranged the pins like this. In another scale, I have done it so that the tip of the pin is touching the virtual image that you are seeing, and therefore from the width of this pin positions, you can say what is the width of the image. Now again, the width of the image or the magnification depends also on the position of your object. If you keep the object at the center, it will have some magnification. If you keep it at behind, you will find that the magnification increases. If you keep it exactly touching the front surface, there was hardly any magnification. So that change in the magnification, etc., children were expected to study and tell the relation between them, how it is changing, etc., etc. Of course, it was not explicitly mentioned in your question paper. You did it because you want to do it. Yeah. I think this is the experiment. I'm just showing you the pictures, how it is being done. Okay, another experiment was to find out the refractive index of the liquid. The same experiment, one part of it was to find out the refractive index of the liquid by seeing something in the normal direction. Seeing an object in the normal direction. So I've taken a jar, okay, and I've put one small dot below the jar as my object, watched it from the top. That point object that I had put over here gets elevated, and therefore you need to find out what is the position of the image with respect to the object. From the length of the liquid from the object and the length of the liquid from the image, you can make an estimate and find out what is the refractive index. We generally call it, it's a standard formula. We find out real depth by apparent depth is equivalent to the refractive index. It is very easily said that yes, real depth and apparent depth, but how do you actually measure the apparent depth was a big challenge. Since the image is a virtual image, how do you locate the image, and you have to find out the distance, the image distance. That was very important, and we did it in a wonderful way. Of course, that was suggested in the statement itself. You take one line, a thick line at the base, and then watch that line from the top and match the line without parallax. So if you are able to take the adjust some reading line over here on this side and match it with the bottom line, then you will be able to locate the position of the image and hence find out the image distance. Many children had also done this very beautifully. So this was also a nice way without any traveling microscope. They do this in the laboratory using a traveling microscope because they want distances to be measured very accurately. At home, they do not have a traveling microscope, yet they could do it. So I have shown over here, you draw one line and change this length, find out when this line and the line at the bottom are in one straight position without parallax. So then you will be able to find out the position of the image. Okay, I think I should enough. Is it enough? Stop sharing.
You're asking the wrong person.
No, it is enough. I think it's enough.
Here, I mean, I would like to, for example, ma'am, just for your facility, can everybody see my screen shared?
Yeah, excellent. Excellent.
So, ma'am, you just see how they're finding out the center of gravity. I mean, this particular photograph was amazing. I mean, just you remember how Professor H.C. Verma applauded the person who had made this. I mean, it was really, and look at the
Wonderful. It is
intricate
Pragya's
way.
work. Pragya's work.
Yes, exactly. And just look at this wonderful way. I mean, could you think of this while making cookies at home? I don't think so. So you see, it was really wonderful. And I'm sure we'll have another time when we would be able to ask her to come and share with us how she also contributed. And so here, can you see my can you see my screen?
Yes. Yes, we're making measurements of the jharna.
Yeah, and then I'd also so 1 second, stop share, and then just for your facility, because I realized that you are having a slight problem in sharing. So you see, I would like to share from her side only. Look at the detailed way in which a manual is given to the students. They're at their home all over the country, and these are school students, mind you. They are not college students. There was a section of college students, and there were more school students. And look at the complexity of, look at the detail of the manual that is supposed to be prepared. So such type of things are providing a source of inspiration to the colleagues, that if you are intending to really teach them while they are at home, then just you can do anything. I mean, this is again another example of ma'am just showed. These are documents prepared by ma'am and her group, Dr. Pragya Nopani and so many others, and Dr. H.C. Varman. You see, this is a manual that was provided to the students. So my only endeavor was that if we can present it to the faculty, because we have here many gathered together, then they too can think of similar experiments. And I'm sure in our country, innovation is everywhere in many minds. So in your own college, you can do it. Thank you, ma'am, so much. I'm grateful to
Thank
you.
you. Thank you really so much.
And
Punita,
I've asked on the chat box
Punita, I would like to add, I was also part of Anveshika. How
yes,
innovative students could be.
Very good.
Clear example of it.
You have to actually
okay.
see to believe. Yes.
Yes.
Ma'am, I would request Dr. Pushpa Bindal, if possible, Dr. Triranjita, Mr. Dr. Yogesh, Dr. Poonam Jain, to also run their videos, so that ma'am can see the invigilators who worked from Delhi University for the NAEST.
And I saw their names when I was preparing the
Dr. Bindal, if
certificates.
it is possible for you, Dr. Triranjita, Dr. Yogesh, Dr. Poonam, and who else? There were many. Who was there with you, Dr. Seema? There were more people.
I don't remember the name actually.
Yeah, but Dr. Yogesh was there.
The lady was from school, I think.
Lady. I mean, from the college, we had Dr. Triranjita. From my college, we had Dr. Seema. And we had
Dr. Sudha Gulati. Dr. Sudha Gulati was also there, but she is not present here.
And Dr. Parul was also there, I suppose. Was it? Yes. Was it Triranjita?
Yes, ma'am. Yes, ma'am.
Yeah, so Parul was also involved, who we heard in the morning, and Dr. Pushpa Bindal was there, and we tried to help this whole initiative. But the best part
Yeah.
was that we ended up learning more than helping.
Yes.
It was both
Exactly.
two ways, two ways.
Yes, it was a
Learning
two-way, and it was,
and teaching.
yes, ma'am. I'm really thankful to you for
Thank
delivering this wonderful talk. There are no words that I have of appreciation.
Dr.
Yeah, here
Bindal
we
is
have
there.
Dr.
Dr.
Bindal.
Bindal.
She is one of our optics expert, as her main field of work is optics. Right from the beginning, she works in fiber optics, and so she was also there. And I tried to convince all of them, let us get together and help this initiative.
Yes, actually,
excellent work, and I'm
it
really
was really,
proud that Dr. Punita Verma is sort of driving all the teachers of her college or her contacts and making them get associated with all top sorts of activities in and around her place and all over India. It's an excellent work, and I'm extremely proud to tell you once again that Dr. Punita Verma is the recipient of the Dinabandhu Sahu IAPT award, and it was in 2018, and I feel extremely proud, not that
19,
because
ma'am.
she has
19,
received it,
19,
but
19.
because she is doing so many different activities for school children, for college children, for teachers. Right now it is for teachers. Fantastic. Keep it up and keep motivating more and more people in and around you.
Thank you,
Thank
yes,
you.
ma'am, for
ma'am.
the nice words. But I must say, we have bundles of sources of inspiration, and you are the epitome amongst so many. And why I mentioned this, in fact, I asked Dr. Pushpa Bindal to mention this award of mine. Why did I do it? I would now state it publicly. It's because physics teachers should know that there is this award of IAPT, which is announced every year, and every any teacher who is doing physics education or educational related work in the undergraduate level. No research, please. No research, only at the undergraduate level. If you are doing anything with the children, with the students, then you can apply if you're less than 50 years of age. So I just kind of, I was just one part here. So, ma'am, that's the advertisement. You asked me that you should propagate it, and I choose the opportunity to mention mine, not to mention mine, but to announce it to the faculty here. If you are an educational teacher in physics, please do apply. Every year
Why
there's a
below
announcement.
50 years of age, Punita? Why the age limit is
That
there?
I don't know,
No,
Dr.
no, no,
Mr.
no.
So
Shankar.
that
That
means
is
award not for us. Not for us.
not for us, not for us. That is true. Actually, we came to know
Why?
about it later on.
Dr. Bindal, you wanted to say something, I think.
Yes, yes,
Yeah.
Sharmistha ma'am. I would really like to point out it is amazing how you could think of all this and how you could actually, interpret everything so beautifully. And, even the students, because I was also part of the evaluators, I was one of the members of the team. I mean, it was amazing how students could implement everything that you suggested. And it was really innovative, really innovative. Some of them
Wonderful.
were pretty good, very good, original thinking. So it was,
I-
it is very inspirational that you can, I mean, people like you can guide the others to think as per, you have definitely an inquisitive mind. You definitely, can interpret and you can, you did think of innovative ways of doing such fundamental experiments and that too at
you,
home
thank you. But
using
it's not
things
me
with,
alone, it's the whole group. Actually, the
I
nest
know, no,
was
no, even
fantastic.
I attended all those meetings, that Professor H.C. Verma and you conducted. It was so beautiful. I must say it was
Thank you.
out of
Thank
the
you.
world.
And
Very,
it's
very
not
good
Punita,
experience.
I think we should have a pic with Dr. Sarmishta.
Yes, I mean, I request everybody to please be kind enough and do not bother about how you are looking, and let's have a pic
yeah,
for
great.
IAPT to hold. And I have written on the chat box, I request everybody. Krishna ma'am, yeah, beautiful,
Yeah,
beautiful.
she is there.
Yeah, please switch
Yeah,
on.
thank you to switch on the videos. Thank you, Swati. Thank you, everybody who's switching on. Please switch on as soon as possible so that we can click some pics and send it to the IAPT. This is the community of physics teachers, which is I'm sure whoever is not a member will soon apply. And it's such a nice thing to be a life member. Every morning you get the boost of physics coffee is what I call you. You open up the IAPT WhatsApp group, and there you have the morning refreshing coffee of physics, and it inspires you and drives you like anything. Ever since I've joined that, I mean, I am enjoying my day thoroughly. So I request Dr. Rashmi Menon, Dr. Bhavna, and everybody else and somebody to take pics. Please quickly, the technical committee also to take pics. I am also taking pics?
And the same is being gone live also on YouTube in the grid mode itself.
Yeah, wonderful, wonderful. I mean, what can be more wonderful than that? That we enjoy this together and we offer everything to each other. And that is what Indian Association for Physics Teachers is about. It is about teachers who work honorary for physics, for the education of physics all over the country. What more can be better than this? And the best part is everything is done while students are at home and teachers are in their home. And I mean, I couldn't think it was better than that. So thank you everybody for switching on your cameras, and I hope everybody has taken also and
I've managed to take
using.
pictures.
Yes, ma'am, isn't it wonderful? So we now request you to think of a day where all of you IIPT people gather together and tell us in detail about these experiments. Friends and brothers and sisters of the physics community, let me tell you, innovative experiments are like, an ice cream, a dessert after your life. You just watch those innovative experiments which the teachers present from the school, and you start thinking, I better go to school. I'm not fit for a college teacher.
Yeah,
They're
all
so
over again.
wonderful.
All over
They
again,
are
really.
wonderful, ma'am. They are wonderful. You can't imagine how nice they are. And then there is an
Yeah.
essay competition for the teachers, isn't it, ma'am? There is an
Yes.
essay competition
Actually,
for the teachers.
the
And
competition is over this time, but for
yes,
next year.
yes, competition for the teachers, competition for the students, and national graduate physics examination, which was held just yesterday. Let me tell you, friends, yesterday in Delhi, in Miranda House, we had all those students who offered for offline examination. They were called in one particular center, and here they had a national graduate physics examination, which can be given only by second, third, and the first year students only of the country. And if they qualify a particular level, they get certificates and prizes, and they get admitted into some institutes of country without giving their entrance examinations of masters. What could be better than this? There are few colleges in Delhi University who are following. Wherever you are, if you're not within this particular domain, then please do apply and you can become a center too of IIPT for holding NGPE. You can yourself participate in innovative experiments. You can participate in essay competitions for your children and for yourself. Ma'am, is my list complete or I missed something?
Thank you very much. Extremely wonderful way of introducing everything to the right group at the right time.
Yes,
Thank you
ma'am.
so much.
Yes, ma'am. Yes, ma'am.
And at the right speed.
And
At the right speed too, yes.
well, I have to look at the time. The next speaker must be cursing me, but nevertheless, we will hear to us her patiently. Also, I have forgotten there are Olympiads held by the Indian Association of Physics Teachers, and they are at the school level. And you must be having children in your family and or in associated family, and you must make everybody aware of these wonderful initiatives. And every physics teacher works honorary for it. So we welcome you all. Let's all become a member of Indian Association for Physics Teachers. Thank you, ma'am. And I must stop, otherwise my colleagues will say you spoiled the whole program.
Thank you very much for this wonderful opportunity. Yeah.